All right, section 6.2. Now we're going to multiply and divide rational expressions. So again, we're going to be looking at these fractions that are polynomials. We'll get to this example in just a minute. But the big thing here is, again, if you can factor, this is going to work out really well for you. So make sure that you practice the factoring. And of course, this is just one big problem set of practicing factoring. So here we go. Basically, here's what we want to do. I have 4 steps for us. And yeah, so let's look at them. First step, is it division? So division question mark. If it is, flip the second fraction. So you'll notice my first example here, not a division problem. We're not going to have to worry about step 1, but we'll do a division problem here shortly. Step 2, factor everything. If it can be factored, you need to factor it. That's really how this is going to work for you. Yeah, I told you, lots of factoring here. Step 3, reduce what you can, and finally, do the multiplication. All right, so let's look at the example I have over here. So I started with an example where the factoring is pretty simple because obviously I don't have a whole lot of room left here on my board. So I have x minus 2 over x plus 3 times x squared minus 9 over x squared minus 4. So the first thing to notice is that even though I said factor everything, some of these pieces don't actually factor. So x minus 2, that doesn't factor. No common factors, no squares. It's basically just, it's just x minus 2. And same thing with the x plus 3 on the bottom. Neither one can be factored. So then we get to the square, to the squares over here. We have x squared minus 9 over x squared minus 4. I picked a couple of difference of squares here so that I could just kind of factor it really quick right in the problem. But normally it's going to be in your best interest to take the factoring off to the side, bring it back, and then clean up the mess. So I factored it, x squared minus 9. 9, remember, is 3 to the second power. So we get x plus 3 times x minus 3. And x squared minus 4, again, 4 is 2 to the second power, so we get x plus 2 times x minus 2. So then I'm looking for pieces that match, and we have some. Now the important thing is you can do this reducing between fractions. They don't have to be like in the last section where we're like, oh look, we have a piece on the top and a piece on the bottom, and they're exactly the same. Here I have an x plus 3 on the bottom, but look, I have one over on the top over here in this other fraction. So I can make them both go away. Same thing with the x minus 2s. I can make them both go away. The important thing is you have to be able to cancel out that whole piece. So when we do that, for the second fraction, all that's left is the x minus 3 over x plus 2. And I wrote in this step just so I could remind you that if you get rid of the entire top or the entire bottom, or in this case both, you're left with ones. Okay, so now we're going to do our multiplication, but 1 times anything is just itself. So we end up with x minus 3 over x plus 2. All right, we'll do a little bit harder example next. Okay, so here is our second example. Oh, notice this one's a bigger mess. This problem took my entire whiteboard, and I even kind of cheated a little bit in places to try and squeeze it in. So anyway, here we go. Hopefully you can see it. I see that my shadow is a little bright there. Anyway, it's x squared plus 7x plus 12 over x squared minus 16 divided by x squared plus 6x plus 9 divided by 2x minus 8. So the first thing to notice is that this is a division problem. So before I do anything else, I'm going to take that second fraction and flip it upside down. Okay, I'm turning it into a multiplication problem. So now I have 4 parts here, and they all need to be factored. So that's what I've done over here on the right. Really wasn't kidding. Lots and lots of factoring in this particular chapter. So you'll see that I have top left, top right, and bottom right. So I'm just referring to the 4 parts here of my fractions. On the top left, we had x squared plus 7x plus 12. Thankfully, we just have x squared at the beginning. We need a pair that multiplies to be 12 and adds up to 7. And I think if you check, 3 and 4 will do the job. So you can see I picked them there. And since we just have x squared, this is going to factor super nice to be x plus 3 times x plus 4. And I brought it back. Then I did the bottom left, which was the x squared minus 16. This is a difference of squares, right? 4 times itself is 16. So it factors very nicely to be x plus 4 times x minus 4. And I brought that back. The top right, now that 2x minus 8, so I'm working with this fraction that I flipped over. The top right, all it has is a common factor. 2 and 8 are both divisible by 2. That's it. I bring the 2 out front, and I get 2 times x minus 4. Finally, the bottom right, we have x squared plus 6x plus 9. If you're really on top of your game, you'll recognize this as a perfect square trinomial. But in the event you don't recognize that, I haven't worked it out. We need a pair that multiplies to be 9 and adds up to 6. That pair is 3 and 3. Feel free to check it, but it works. And so since we just had x squared, it's x plus 3 times itself. So I brought everything back, and you can see I already went through and crossed out all the pieces. We had a pair of x plus 3s that could go away. Notice I can't get rid of this other one. I didn't have a second one on top to pair it with to get rid of it, so I can only get rid of the one. Then I got rid of the x plus 4s, the x minus 4s, and when all that was done, all that was left was 2 over x plus 3. Okay, so that's a really good example. I will say this, if you happen to have, let's pretend for a second that this x minus 4 didn't go away right here, that it was still there. If that happens, you don't need to multiply those two things out. You are more than welcome then to leave it as x minus 4 times x plus 3. Just put them both on the bottom, just kind of smash them together, and that will be perfectly acceptable. So there you go. That's reducing these multiplication problems. The reducing itself is actually pretty easy, but you do have a lot of factoring that you're going to do. So these homework problems tend to be just a little bit time consuming, although they are very, very good practice for factoring. So good luck.